Hello everyone and welcome to this new episode of Open Source Contribution Guide where we choose a project randomly from the internet and contribute to it and learn how to build it, set it up, and also some of the foundational skills which we need when we are making a pull request to make sure that we are a good open source contributor. For this episode, we will be dealing with a library called PettingZoo, and this might sound like a funny name, and it actually is. So let me give you a brief idea of what PettingZoo is. So PettingZoo is one of the repositories maintained by the Pharma Foundation, and the Pharma Foundation maintains a list of different repositories which are generally centered around building environments for reinforcement learning. So you might have heard about the OpenAI Gym, which has now been renamed to Gymnasium, which is also maintained by the Pharma Foundation. The OpenAI Gym is a single agent reinforcement learning framework versus PettingZoo, which we are going to deal with today, is a multi-agent reinforcement learning environment. So let's get started and we'll pull up our 13-step contribution guide and we'll follow it to make sure that we are contributing to this repository in the right order. If you're unfamiliar with this 13-step guide, there should be some video card up there. All right, so let's start contributing to the Pharma Foundation. Looking at the 13-step guide, we skip the first step, which is finding the project because we already have a project in hand. The next step is reading the contribution guideline. Remember, when we read the contribution guideline, there are two different files that we have to look into. The first one is readme.md, and the second one is contribution.md. So let us scroll down. The README gives us a brief introduction of what PettingZoo library is, the different kinds of environments it supports, the installation instruction. Always remember, usually installation means how can a user work with this library. It is not how can a developer contribute to this library. So be mindful of that. Then we have some getting started links. We have some API documentations, parallel API, environment versioning, and a citation. Okay, it's a relatively shorter README. And then we'll go to contribution.md, or in this case, contributing.md. In the contribution guide, it does give us a few steps to install it. It does say that we have to use pip install -e dot. Remember that most of the time when you're installing something locally, you will use this -e flag. What it means is editing, right? The E stands for editing or editable. And what that means is you really want this library to be editable. So any changes you make to the source file should be reflected when you're running a code that depends on these files, right? And that is exactly what we want. We want to see how our changes take effect when you're trying to test it out. And then just running pytest -v. Pytest -v is something specific to this repository. It just runs a bunch of tests. Basically what we call as unit tests to make sure that we're not breaking any changes. And for now, it seems that these are the only steps. We'll go through these steps in detail when we are trying to set it up locally. It has some information about pre-commit hooks, which is a very good thing in this repository. It's a very unique thing, and very few repositories actually have it. Pre-commit hooks are basically some pre-commit checks, or as the name suggests, some checks that we do before we commit, and it makes sure that we're not breaking something. So these pre-commit checks are very useful in order to make sure that you're not pushing in a breaking change. So next up, we have some commands just to run these pre-commit checks. There are some tutorials that this repository supports. In this video, we won't be contributing a tutorial, but if you were contributing a tutorial, you should read through this section. In this particular video, we'll be actually fixing a bug, and we'll see that issue very soon. And that is the end of your contributing.md. So the next step in our 13-step contribution guide is to look for relevant issues. For this particular video, we already have an issue picked up. As you can see, this is a closed issue because I have submitted a PR that does fix it. But let me give you a brief overview. So there is some strange behavior in the multi-particle simple tag rendering environment. So simple is a category of environment that PettingZoo supports, and what the user noticed is that the behavior that the rendering shows does not align with the rules of the environment. For example, the gray circles that you see over here are actually obstacles. And by design and by definition, these obstacles are fixed in the environment. But in this rendering, we can clearly see that they are moving. And they're not just moving, the distance between them appears to be getting smaller. And the reason this happens is because as the agents move towards the boundary of the screen rescales. And this rescaling causes these two different obstacles, or rather any object or agent on the screen, to actually appear that they are moving closer to each other. Think about it this way. If you're zooming in into something, but the size of these particles continues to remain the same, which is the case over here. You can see the radius is not changing, even if you're rescaling the window. What happens is that the relative distance between two objects tends to increase or decrease depending on if you're zooming in or out. And this creates a lot of confusion. As you know, in this environment, they're not supposed to move. And actually, if you print out the coordinates, they are not moving. But the rendering makes it feel that they are actually moving. So the fix to that is rescaling the sizes. There's quite a bit of discussion that went ahead before coming up with a solution. But I realized that if you actually have some rescaling done, for example, this is a GIF of what happens before dynamic resizing or rescaling, and this is what happens after dynamic resizing. So over here, you'll see the radius remains constant, but here, as we zoom out, the radius decreases, and this gives the right interpretation that the distance between the two objects or any two agent does not change with rescaling. It's just that they are getting smaller or larger based on if you're zooming out or zooming in. And that is what you wanted to implement, this dynamic resizing. So we won't really go in the exact coding details how to do this. It's actually quite simple. You just have to make sure that you're keeping in account the original size of the window, and you're rescaling it using the current size of the window. That's exactly all you have to do. But given that this is the issue, we now go on to our next step. So now we need to fork and clone the repository. To do so, we need to go to the coding tab, click on this arrow over here, and over here you can see I already have an existing fork. So when I go over here, you'll see that there's an option for me to sync the fork. I won't be syncing in the fork because if I do it, I'll get the changes that fix this issue within my branch, and I won't be able to reproduce the issue without tweaking the code. But if you were contributing to it and if you had a stale fork, you should always update it. And once you have forked your repository, the next step is to clone it. And to clone it, you just need to click on this arrow beside the green code button, copy the HTTPS link, and go to wherever you want to store it. So I have a folder created over here called demo, and I will be opening my git bash here. If you do not have the git bash CLI installed in your Windows or any operating system, there will be a link in the description of the video that goes over the installation process. Okay, so we have our demo folder over here. We need to clone it. So we'll be doing git clone and paste the URL that we just copied. Once we have cloned the repository, the next step is to create a new branch. So we create a new branch, and let me just call this fixing, or rather implementing dynamic rescaling. My bad, we first need to get within the repository and then create this new branch. Okay, so we have created the branch, and the next step would be to set up a virtual environment. To do so, I would be using the WSL, or the Windows Subsystem for Linux, which is a wrapper of Linux on top of Windows. If you don't have WSL and if you want to do this, there's a link in the description which will help you to install WSL. If you're having Linux, you can directly follow this because WSL is a Linux interface. And if you have Mac, the commands might differ a bit, but you would probably have a similar experience because both of them are Unix-based environments. To create a new environment, we need Python 3 -m venv and the name of the environment, which I'll just keep as env. Remember, Python 3 is for Linux. For you, Python just might work. You probably don't need the 3 over here. Once we have our environment created, the next step is to activate it. So before I activate it, let me clear my screen and increase the size so that it's more legible. In Linux, the code for activating it is source, followed by the name of your environment, the bin directory, and activate. If you see an env on the left-hand side of your command, it means it has been activated. And the next thing we need to do is follow the repository's instruction on how to install this. So the commands are pip install -a dot testing all. So let me just copy this. We go back to our bash, sorry, WSL. We don't paste it over here because you should always run this within your PettingZoo library. So we go one step closer to the PettingZoo library, and that is where we run this command. So this has taken its own sweet time, and I'm actually becoming lazy because it is night, but we still have work to do. And as you can see from our screen that we have successfully installed it. For some of you, it might not go this smoothly. Sometimes I did face some errors when I was trying to install it. Always remember that in the README, they do mention that you will need Swig and AutoROM installed. So if you're using Linux, you just have to do sudo apt-get install Swig and AutoROM. So if you're facing some errors, do make sure that you have both these libraries installed. If you do not have it installed, I'll also recommend doing a sudo apt-get install update so that you get the latest version of your package manager and all the libraries that you're installing. So that is installation. The next step is to run pytest -v. Now, when you run pytest -v, what is going to happen is a bunch of tests will run. You'll also have a few windows popping up, and I won't just leave you hanging, dreaming what's going to happen. I'll just run this command right now, and you'll see what's going to happen over here. So it'll run a few workers parallelly, and you'll have a lot of these different pygame windows pop up. Let it do its thing. At the end, I'll come back again and I'll show you what is the most important part of it when you run this command. So we are now done with all the test cases being tested out and run. And as you can see over here, we have 84 test cases which are failing, 168 which are passing, and 76 warnings. It is important to take a screenshot of this when you're starting to contribute because you do want to know what is the current state of the unit test. Because once you make your changes, you want to make sure that you're not adding more failures to it, right? It's always good if you're making some more tests pass, though I would be a bit skeptical about that too if that was not your intention. So it is important to understand the initial state and the state of the code base after your changes. So now we are done with the, I would say, boring part of it, or the parts where you're most likely to face an error. The next part in our contribution guide is to actually make our changes. Whenever we are fixing a bug, it is always a good practice to include code which can reproduce these bugs. And if the initial person who created the issue does not include the code to reproduce it, feel free to ask them about a code sample that does. It's to your right, it makes your debugging job way easier, so it's always a good practice to ask. Fortunately, in our case, this is a perfectly well-structured issue which does have a code sample which we can run to reproduce it. So now I'll open my trustworthy VS Code. So let me open that up. And I've already copied this code example in a test file, so I'll be bringing that in here too. So let me clear my screen and let me copy the test file I have created into my new environment. Okay, so navigate to the repository where you have your PettingZoo installed, and I copied the code I got from the issue into this test.py. Now for this particular video, I won't be running the test.py. And the reason is this is very specific to the issue we are solving. This video is about giving you a broader idea of how to solve your problems. So have a script like this that helps you reproduce it. But once you have a script of this nature, the next step is to focus on the issue at hand. And in our case, what we will find is that there's a problem with an environment called the simple environment. So we go into the PettingZoo library. Within the PettingZoo folder, all these repositories that you see over here are categories. So Atari actually is a Atari game category where you'll have a lot of different games within itself. So you have boxing, combat plane, combat tank, etc. The ones that we are currently more interested in is the simple one. The simple is a part of MPE, which I think is called multi-particle environment. That's what MPE stands for. And you have a number of simple environments. And here, the problem is in the rendering. And the way these environments are structured, especially the simple environment is structured, is a bit hierarchical. So we have the simple.py, which is, or rather not this simple.py, but over here simple environment.py, which is like the base class, which is used as the base class for all the different simple environments. So all the different simple environments are evolved from this simple environment class. So they are made from it. And this reverse tree structure is what is responsible for rendering too. So this simple environment.py has a function called render. So this rendering function is responsible for rendering all those Pygame windows that you see for all the simple environments. So the problem in this issue lies in this render module or render function. And this is, again, very specific to our use case, but it's important to understand how you read these codes, right? You need to understand how they're connected. For example, in this case, we identified a hierarchical structure. The issue, however, was only complaining about one single environment, which is called the simple tag, which you'll see somewhere over here. So simple tag is a part of the simple environment. But that issue actually persists with all the different simple environments. So as a good software engineer, you should understand what the user's issue is, but you should also find the root cause of it, right? Just solving it for simple tag does not solve the issue because it still persists in different environments. Now, I won't blabber much about it and I'll actually dive into the code which fixes it. So let me get you to my pull request. So in my pull request, I'll actually take you to my first commit, which is easier to read than all the rest of it. So what my first commit does is that it introduces a global variable in this file called dynamic rescaling. By default, it is false. And what we try to do is we get the original cam range. The cam range stands for the current size of the window. Once you get the original cam range, we also get all pauses. So the way we get the cam range is that we get the position or pauses for each of the different agents or entities over here. And the maximum of it, the ones that are on the boundaries, are given, are responsible for the range of the window. So there's always one element at the boundary of it that determines the size of the window. And that is our original cam range. Now, every time we have a new rendering, we calculate the current cam range, which is just called cam range, and the ratio between the original cam range and the current cam range. And 0.9 is just a factor to make it not too out of bounds. It's more of a heuristical factor. So this gives us a scaling factor, which is basically the ratio of the initial size we began with and the current size of the window that we are playing with. And this scaling factor is used to scale all the entities when we are drawing it and rescaling the radius of these entities to be specific. And that's what's happening over here. In my subsequent commits, there's actually a better way of implementing it, which was pointed out by a maintainer, is that let us give the user the ability to toggle between whether they want dynamic scaling, rescaling on or off. And this leads to a bit more involved change. It's just that I need to reproduce this option or argument and add it to all the different simple environments. So it creates like a big code change. But in the essence of it, it is just the change I explained. It is a scaling factor which gets multiplied with a radius, and that solves our issue. And again, the test.py that I introduced over here can be used to check it out and make sure that we have the desired behavior. And that is how you should tackle any issue in this library or any other library. Understand the code, make sure you're targeting the root cause of the code, and then testing it out. Again, this test.py is not enough. This will only reproduce this particular use case. Before we went into the PyTest framework of this repository. So you should also run the PyTest -v after this has happened to make sure that we're not failing any additional tests. Once we are done with this and it is time to commit, that is when we need to, do you remember? We need to run the pre-commit checks. So we go to contributing.md and the first thing it tells us is that we need to install pre-commit. So let's go ahead and install pre-commit. So pip install pre-commit. Once we have installed the pre-commit, the next step is to use this command pre-commit run all files. Actually, I missed a step over here. The next step is pre-commit install. Once we are done with this, then we run pre-commit run all files, and this should run all the pre-commit tests that are within this configuration. Some of these tests include like formatting changes to make sure that your code is formatted well, and these will also run when you push to the main branch or when you create a PR, because these are also the automated CI/CD tests that take place. But before you merge a pull request, make sure that you run, before you create a pull request, make sure you run these pre-commit checks, because you don't want to open a pull request when some of these are failing. I'm guilty of that. I did not run all of these and I felt some of them were not related to me or to my change. And once you do that, you create a pull request. And I won't wait till the pre-commit check actually runs because it does take quite a bit of time. Rather, I'll take you to the pull request that I have created to give you an essence of what it looks like when you're contributing to a repository like this. And in my description, I gave a brief description of what the dynamic rescaling actually does. It's a new feature, so it has to be a bit more descriptive. You should always link the bug or the issue number that is being fixed. So just saying fixes, the number of the issue should be sufficient. And the type of change is a bug fix, it's a new feature, and it also requires a documentation update because we added a new argument. So a part of my pull request is also some documentation changes. And the changes are pretty simple. Every environment that you deal with will have the documentation embedded on top of it. So if you scroll up to any of the environment files, not the simple environment, any other environment file, you'll find a list of documentations. So it goes over the arguments, explains when to use it, and this is the change. If you want to change the document of an environment, this is where you should focus on. That's the top of any of these environment files. While talking about documentation change, I'll also like to mention that there is a different contribution guide for the documentation change. You should look within the documents folder, which is actually labeled as DOCS or docs. It will have its own contributing guide and it has its own steps of how to render these documentations. They're quite simple as compared to the normal code installation, so I have skipped them. But if you want to make a documentation change, do visit that guide. Next up, I added a few screenshots. It's always good to add some screenshots of before and after so that the person does not really have to run the code or run the sample code to test if it's working fine. It gives them a sense of assurance that, okay, the code is having an effect as desired. It is running as expected. Next up, they also have a checklist, so make sure that you have followed this checklist. In my case, I have not added tests to check for this particular feature. I probably should have, but I don't have a very good idea of what kind of tests would be necessary for this. This could be an area where you could contribute to, so feel free to always improve on everyone else's work, including mine. And there has been a bit of discussion, a good friendly banter over here, but again, the essence is make sure that your pull request is easier for the reviewer. And you can do that by adding a few screenshots of before and after, by following all the pre-commit checks or any checks that your PR needs, and by making sure that your code is well documented and well structured. Once you're done, and once you fulfill all the requirements of the reviewer, it should be merged as usual, and it does take time. For example, this one took a month to actually merge from the very start of my PR. So be patient, be passionate, and contribute to open source. It's a great journey. It's a very rewarding journey. And that concludes our open source guide of contributing to PettingZoo. I will come back with another repository. If you have any suggestions of which are repositories I should cover next, please link them down or add them down in the comments below. And if you like my video, please like, share, and subscribe. I'll continue making such videos. Thank you and have a great day. See you.